Hi, it is me, Mrs. Camp, and we are going to do another strategy, a different approach to solving some of those tougher Math Olympiad problems. This one I love because it is a strategy that I use all the time in my everyday life just to get through the day. So if I have a lot of things to do or a lot of stuff to organize, what do? I make a list or put it on a table so I can keep all of the information organized. And that's what we're going to do today. How many of you have rooms that look like this, right? I know that some of my kids, that's what it looks like. And if I say to them, go clean your room, they're like stuck, right? There's just too much. They don't know what to do. And so what do? You make a list or you make a table, things to, different ways to organize the information. And so you can quickly get through the big task. It's the same thing with math. You ready? So in order to do this video, you need something to write on, something to write with, and be ready to pause the video because I'm going to make you do some work along the way. You ready? Here we go. All right, a bank has two plans for checking accounts. So that's where you're going to deposit your paycheck. In plan A, the charge is $7.50 with no fee for each check that you write. And in plan B, the charge is $3 a month plus an additional 20 cents for each check that you write that month. Okay, so what is the least number of checks a customer must write so that plan A costs less than plan B? Okay, so if we're figuring out, we need to figure out which plan should we go with. We want to know the parameters and how many checks we can write before maybe plan B would be a better option. So what I'm going to do is set up a table. Okay, I got to think about what numbers of checks I'm going to write and what plan A, they say it's $7.50 a month. Plan B is $3 a month plus that 20 cents per check. Okay, so if you do one check each month, plan A, it's going to cost you $7.50. Plan B, however, is $3.20, right? And so if you're never going to write checks, obviously you're going to go with plan B with this one. But what if you we could now, in this table, here's the thing about tables, guys. We could go now, how many for 2 checks, 3 checks, 4 checks, 5 checks. But let's look at the difference right now between plan A and B. It's pretty big, right? Between about $7 and about $3. And so I don't want to just go to 2 checks, right? Because I know that 2 checks is, only going to get me a little bit higher. So my next one, I'm just going to write to 10 checks, okay? And you could go by 5s. What you grow by in your table is up to you. But if you can use your number sense to figure out that if going right to 2 would take you more time, and remember, we're on the clock here, then think, how can I be more efficient with my choices, okay? So tap into that number sense of how $3 plus 20 cents per check will grow each time, okay? Because we know that plan A is never going to grow. So if I write 10 checks, I have to pay the $3 plus 20 cents for every 10 checks, right? So 20 cents times 10 gets me to $5 a check, okay? Go ahead, see if you can fill in your chart. Let's double that. What would happen if we got 20 checks? Because I think we're still far enough away from $7.50 with plan B. We should just double it. Go ahead. What would happen? Well, if you had 20 checks in plan B, you have your $3. And then you have 20 cents times 20 checks, right? So 20 times 20 plus, but a decimal of 20, okay, plus that $3, you are now at $7 for your plan. Okay, now we are close to $7.50. So I don't want to go right to 30 checks because $7 for plan B and $7.50 for plan A, we're getting close. So now let's increase it by 1 check each time. Okay, the math should be easier now because you have the base of for 20 checks, it's $7. If you had 1 more check, you're really only increasing your cost by how many cents? 20 cents, right? So hopefully now you're like, okay, now this table is going to make it fast. So let's go up 1 more check. What's your cost going to increase by? So 22 checks, you're now at $7.40. Okay, is plan B still cheaper? It is, right? What about if you write 23 checks? You are now at $7.60. So let's go back to the question because we've surpassed that $7.50. What is the least number of checks a customer must write so that plan A costs less than plan B? If they write 23 checks, plan A is going to cost less, right? So anything 23 anything equal to or greater than 23 checks will make Plan A the better option for them. All right, ready? Let's go on. Okay, this one's pretty fun. The only way 10 can be written as the sum of 4 different counting numbers is 1 plus 2 plus 3 plus 4. Okay, you could try that out. See if you want to pause the video and add a little extra challenge, and you can. See if that's true, but I'm telling you, it is. And how many different ways can 15 be written as the sum of 4 different counting numbers? So for this one, though, we're going to assume that order doesn't matter. So we know with the commutative property, let's go back to the 10. 1 plus 2 plus 3 plus 4 is 10, but so is 3 plus 4 plus 2 plus 1. Order doesn't matter in the commutative property of addition. So we're going to assume that order doesn't matter when we're trying to figure out how many different ways we can write 4 different counting numbers that will have a sum of 15. So the way that I'm going to do this is I'm going to think of 2 counting numbers that equal 15, and I'll break those down. So I know that 9 plus 6 and 6 plus 9, remember commutative property, both equal 15. But I need to break these numbers down into sets of 4. And if we start with 9, that's really our only option for those 4 numbers. But what if we start with 6 and we just leave 6 as it is? We could do 6 plus 5 gets us to 11, plus 3 plus 1 gets us to 15. All right, start with 6 again. What other 3 digits, okay, we can't just switch the orders of 5, 3, and 1, but other 3 digits could get us to 9 if we have a 6? Did you come up with 4 plus 3 plus 2? Yeah, all right. So far we've come up with 3 different ways. So what's another 2-digit sum that would make 15? 8 plus 7 or 7 plus 8. So let's start with the 8 plus 7. So if we start with the 8, let's break up the 7 into 3 different digits that would equal 7. I did 4 plus 2 plus 1. We start with that 8. There's no other way to make 7 other than 4, 2, and 1, right? But what about the smaller digit, the 7? Let's start with the 7. What 3 digits could you break up to make 8? My first thought was 5, 2, and 1, okay, which would make 8. What's another way? What about 4, 3, and 1? Absolutely, right? So we're just scaling the numbers differently, right? We moved the 5 down to the 4, but the 2 up to the 3 to scale the numbers. All right, I think we got them all in this list. And so how many did we come up with? We have 1, 2, 3, 4, 5, and 6. Not too bad, right? Yours might be in a different order than mine, but remember, commutative property, the order doesn't matter. We're still reaching 15 with 4 different numbers. All right, you guys ready to try it on your own? I think so. Let's do it. Let's look at this one. Okay, if a 3-digit number is divided by 5 or 6, the remainder is 1 in each case. What is the least such 3-digit number? Sorry about that. All right, so we're going to take a 3-digit number. Let's break this down real quick, right? First, you got to know what the question's asking. And if you divide it by 5 or if you divide it by 6, you'll have a remainder of 1. So what is the smallest number that would meet that requirement? Go ahead, give it a shot. What table could you make that would help you figure this out? Need a hint? Think multiples. It is a common multiple of 5 and 6. Think about what the common multiples of 5 and 6. Because remember, you're going to divide both of them by 5 and 6. Go for it. All right, how'd you do? This is what I did. I wrote a multiples chart, right? Again, I'm tapping into prior knowledge. We've done lots of multiples. You started those early on when you were working on your multiplication facts. And so I'm going to tap into that to answer this question. So first, I'm just going to list only the 3-digit. Remember, I don't want to waste my time listing 5, 10, 15, 20, right? I know it has to be a 3-digit number. So the lowest 3-digit number that's divisible by 5, of course, is 100. And it goes all the way up by 5s. I'm going to stop at 130. I can go back if I need to, but I see a number in there that I think is going to work for me, so I'm going to stop. All right, what about the multiples of 6? The first, I started lower, honestly, because my 6 facts, I just thought, okay, I know that 6 times 12, right, And so I started with my 12s because that's where I'm not necessarily fluent in 6 times 13, 6 times 14, 6 times 15, etc. Right? Maybe you started at 102. Okay, either way works for you, but definitely don't start with 6, 12, 18. Okay, let's not waste our time. Remember, we want to be efficient because we are on the clock. So once I get to the 3 digits, okay, I see one that's the same on both lists. Dun, da, da, da. 120 is a common multiple of 5 and 6. It's the least common 3-digit multiple of 5 and 6. But now we go back to the problem and we see that I'm going to divide it by 5 or 6, but I'm going to have 1 left over. So it has to be 1 higher than 120. 121 divided by 5, I'd have a remainder of 1. Divided by 6, I'd have a remainder of 1. How'd you do? All right, do you want to do some more practice? Here's what you want to look for when you're looking at Math Olympiad problems. If you have a complex problem with many different types of information coming at you at once, okay? If you've done the drawing a picture, that helps too. The list or a table just kind of gives it a little bit more structure and purpose when you're solving it. Or if you have to create data, or when a problem has many steps, okay? All of those scenarios in a Math Olympiad problem might lend itself to a list or a table to help you organize your thinking and make the answer more obvious and more easy to come by. How about some more problems? Here's a couple in a couple other books for you in Volume 4 and 2. All of today's problems came from Volume 3. And as always, the Math Olympiad website has some great problems that change often. I would highly recommend you check that out as well. Keep up the good work, guys.